YouTube traffic, this is 345 Delta Foxtrot, ready to record another YouTube video. YouTube traffic. This is my standard disclaimer. If you haven't already seen it, please take a few seconds to check it out. Well, it's been a little while since we've seen each other. I've been a little bit negligent about making these YouTube videos. Sorry about that. There are things to do in life other than make YouTube videos. I'll try and do better. This video is going to be the first video in a little series of videos about rivets. And in this video, we're going to primarily talk about tools for riveting. And some of you may already be somewhat familiar with riveting and the tools that you use to do it. However, I think I can toss out a few tips along the way that you may not be familiar with. And so I would encourage you to watch it unless you are a very experienced riveter. Okay, like I said, this is the first in a series of videos, and the next video is going to be on the strength of rivets. And then the video after that, I built a little apparatus for actually measuring the strength of rivets. So we're going to go down to the shop, and I'm going to show you how I actually measure the strength of rivets. And we'll only do a couple of examples. Once you've seen it, you don't need to watch it, every time. It would be kind of boring. Then the videos after that will be about the measurements that I've made, and they'll just be summary videos of how the data came out. And all of the videos up till there are going to be about solid rivets. And then probably the last video in this series will be about bind rivets, or pulled rivets, or pop rivets, or whatever you want to call them. Okay, first, just a very quick introduction to rivets. I think I've actually shown this slide before. Here's an example of a rivet, an AN 426AD 3-4. The AN stands for Army Navy. 426 is the head shape, and 426 is a countersunk head, and the primary alternative is a 470, which is a round head or a universal head. The AD is the alloy code, and AD specifies an aluminum 217 alloy with a T4 temper, and those are often referred to as hard rivets, and those are the ones you want to use. That's why they're in green. There are also, there's several other alloy codes, as you can see in the chart to the right there. The ones with a dimple are the AD rivets. The ones with nothing on the head, just a smooth head, those are the type A rivets, alloy code A. And those are often referred to as soft rivets. And those are basically pure aluminum. They're the 1100 alloy. And there's several other different types, but probably less common. And for all structural applications, I think you're going to want hard rivets. I don't really know of an example of when you would want to use a soft rivet. However, I will tell you a little mistake I made. I ordered some rivets from Aircraft Spruce, and they arrived, and I looked at the package, and these are not the right rivets. These are type A rivets and not type AD. And I got ready to send Aircraft Spruce a nasty email saying you sent me the wrong rivets. And then I found out that it was actually my mistake. I actually ordered the wrong rivets. So those rivets went immediately into the trash because they're just a mistake waiting to happen. Like I said, don't use type A rivets unless you know exactly what you're doing and why you're doing it. Make sure that all the rivets you use are type AD rivets. Then the 3 at the end is the diameter of the rivet in 30/2 of an inch. And in this example, it's a type 3 rivet at 3/32 in diameter. And the -4 is the length of the rivet in 1/16. So in the example here, it would be 4/16 of an inch long or 1/4 of an inch. Okay, the first tool that I want to talk about is actually the Rivet Gauge, which might seem a little bit odd, but that's where I want to start. So here's the Rivet Gauge sold by Cleveland Aircraft Tools, and it's quite a good gauge. It's very nice. It's a one-piece gauge. The ones sold by Aircraft Spruce are here, and there's one piece for each different rivet size, so it's a little bit different. I have the Cleveland Aircraft Gauge, and so I prefer it, but that may just be because I'm used to it. The Rivet Gauge has large indentations along the bottom, and that's for measuring the length of the rivet before you drive it or set the rivet. You want to just make sure that the rivet that you're using has the right length. And so this is the appropriate length for a type 3, and then right next to it is the appropriate length for a type 4. These other two are for type 5 and 6 rivets, which I don't think you're going to be using. It'd be pretty unusual to be using rivets that large. And then it has holes for measuring the diameter of the shop head. This is after you've driven the rivet. And it has notches. You can see it easier over here on the right side. Has little notches in the corners, and that's for measuring the thickness of the shop head. Let's see. So the big notches are for measuring H, as shown in this picture here. Then the hole is for measuring W, and the little notch in the corner is for measuring T. If you go back to their website, it says view instructions for this tool, and then it refers you to a file. Well, that file does not exist. There are no instructions for this tool. If you actually contact Cleveland Aircraft and find out what happened to these instructions and get a copy, please post a little note, a comment to this video. But as far as I can tell, these instructions do not exist. However, Mike at Cleveland Aircraft does talk about this rivet gauge in one of his YouTube videos, and it's given here. The title of the video is Hangar Hangout, February 3rd, 2022. And he clearly says that the rivet gauge is for measuring the ideal dimensions of the rivet, not the worst case dimensions. Or I believe his word was ideal, but you might also think of it as the typical case for a rivet. Now, for the Aircraft Spruce gauge, it's different. On their website, each gauge measures the minimum height and minimum diameter. Now, I don't know if they're actually using different dimensions or if they're just using different wording. However, there doesn't seem to be a common standardization on what these rivet gauges are supposed to measure and how they're supposed to measure them. I personally, like I said, I have the Cleveland Aircraft gauge, and I'm going by what they say and their recommendation, and I believe that that's correct. We're going to be talking about this more in the next video, and then we're actually going to make some measurements, and hopefully we can lay all this completely to rest and know exactly what we're doing at the end of this series of videos. Okay, I think that's it for the rivet gauge. Oh, no, it's not it. So I actually measured the dimensions of my rivet gauge to see how it was set up, what it was actually measuring. And the big notch is, the dimensions are given here, but basically the big notch is 1.5 times the diameter of the rivet, which is very often that's what's quoted as the correct length of a rivet to use, 1.5 times the diameter. And there's not an infinite number of rivet lengths to choose from, so basically you just choose the rivet length closest to that value. The hole is also 1.5 times the diameter of the rivet. And I have some reason to believe that that is a good number for a typical rivet shop head diameter. Like I said, we're going to talk about this more in the next video, and we're actually going to make some measurements to verify it. And the small notch is 1/2 diameter. And again, I have some reason to believe that that would be a good typical number to shoot for. But it's not necessarily the worst case number. Also, the way the Cleveland Aircraft tool is set up to use the small notch to measure the thickness of the shop head. You basically have to measure the distance between the top of the dimple and the shop head, not to the skin. The little notch in the corner is too small to measure the distance from the skin to the shop head. However, if you look at the Aircraft Spruce gauges, it's different. In that case, you would be using this notch right here to measure the thickness of the shop head, and you would be measuring to the distance from the skin. So, you know, they're not measuring the same way, the same thing the same way. They're definitely somewhat different. I don't know, as far as I know, Aircraft Spruce does not provide any instructions to go with their rivet gauge set. Okay, one thing that you can do, I guess you could consider this a tip. The rivet gauge is not very expensive, but you don't have to buy one. You can basically make your own. All you need is a nice little ruler. I would use a little 6-inch steel ruler, and you can measure the to determine what size of rivet to use, to measure H in the drawing. To measure H in this drawing here, you can just use a good ruler. And for number 3 rivets, you just pick the rivet size bigger than, the first size bigger than about 3 millimeters. And for number 4 rivets, you would pick the size closest to 5 millimeters. Or you can, you know, use the value of your choice. That's the number that you get if you want to do 1.5 times the diameter. Now that's not written in stone. If you want to use a little bit longer rivets, if you think those are better for some reason, you know, you can change the number that you measure here. And then for measuring W in this drawing here, measuring the width of the shop head, just drill the appropriate size hole in a piece of aluminum, a little, you know, maybe a 1-inch by 4-inch piece of aluminum. And you could bend it a little bit if you want a little angle to make it easier to get it in and over a rivet. Here's some possible values that you could use. For a number 3 rivet, you might want to use 1.3 times the diameter, which would be a number 31 drill bit for your smallest hole. If it's smaller than that, it's almost certainly not going to hold. Then you can drill a 9/64-inch hole for your typical, which is basically the way the Cleveland aircraft gauge is set up. It's set up for 1.5 times the diameter. And then to see if it's over squeezed, see if the diameter is too large, you could use a number 19 drill bit. And that was all for number 3 rivets, and you just use different drill bits for number 4 rivets. If you want to do the same thing, 1.3D, 1.5D, and 1.75D, then you would use a number 20 drill bit, a 3/16 drill bit, and a number 1 drill bit. Okay. In my opinion, the best way to rivet, the way that gives you the highest quality rivets is by using a squeezer. So whenever possible, I always use a squeezer. Now, of course, you can't always use a squeezer. When you have a rivet right in the middle of a large skin or something, there's no way that you could get a yoke in to squeeze a rivet. The standard yoke is a 3-inch yoke, so you have to be within 3 inches of the edge in order to use a squeezer. You can get a 4-inch yoke, so you could get in a little bit further, but you are limited basically to just squeezing rivets near the edge. So this is the standard squeezer sold by Cleveland Aircraft Tools, and it comes with an adjustable set holder, and they sell it separately, and that's what it looks like. This is the ram that the squeezer pushes from the bottom of the squeezer up toward the yoke in order to squeeze the rivet. And it's adjustable, it's threaded, and one turn of the ram, if you unthread it by one turn, that squeezes the rivet by an additional 1/32 of an inch. And if you turn it the other way, so that you're threading it in, then it's a 1/32 of an inch looser. And I think that these are great. I think that they're definitely the way to go. They are an adjustable set holder like this is not cheap, but you're going to be doing a fair amount of squeezing, and I think it's well worth it. So my recommendation is to go with an adjustable set holder. Even if you purchased a used squeezer or something, try and see if this will fit, and you can convert your squeezer so that it's adjustable. I think you'll make your life a lot easier. And I've already mentioned some yokes. There's quite a few different yokes that are available. The standard yoke that they ship with the RV10 kit is this 3-inch pneumatic yoke here, the first one. Oops. It's this one right here. Then I think the second most popular yoke is this one right here, the 2.5-inch flange nose pneumatic yoke. And I believe that would be my recommendation for the second most useful yoke to purchase, and I believe that Cleveland Aircraft Tools makes the same recommendation. After that, you might want to consider one of these thin nose yokes. For example, you could get this 4-inch thin nose yoke, and that would give you a 4-inch yoke, so you can get in a little bit further from the edge, and it would also give you a thin nose yoke. Now, I'll warn you that these thin nose yokes, the nose is thin, but it's not all that thin. For example, if you build the Vans airfoil practice kit, there are some rivets that are very difficult to get to. And one of these thin nose yokes, I believe it will let you get to the next to last one, but not the last one. So it's kind of a marginal usefulness. But like I said, it would be a way to, you would still get the 4-inch yoke, which you might find useful. And there's several other yokes shown here. Now the nice thing about Cleveland aircraft tools is they have videos about their tools, and there's some listed here, and their videos are good. I recommend that you watch them all. Now, there are other squeezers available. For example, this is one of their manual squeezers. I think they have a cheaper one as well. Now, the Numatx Squeezer that we've been talking about is about $600, I think. So it's not a cheap tool, but you're going to be using it a lot. So you really want to think seriously about buying it. I recommend that you buy the pneumatic one. But I want to point out that there are alternatives available. Now, if you have some money burning a hole in your pocket, you might want to consider this Numatx squeezer. And I've never actually used one, but I've seen people on YouTube use one, and they look very nice. The nice part, well, actually it has kind of two nice parts. One is the body of the squeezer is much smaller and lighter, so it's very easy to get in and precisely squeeze a rivet. And the other nice part is it has a foot pedal. If you have reasonable hand-to-foot coordination, it should be a very good way to, that it will allow you to use both hands to get the squeezer in exactly the right place, and then use your foot to actually activate the squeezer. But it's even more expensive. I'd like to try one. If anybody has one watching this video, if you have one, please leave a comment on this video about how you like it and whether or not you would recommend it, whether it's worth the money. Okay. Actually, there's one other thing I wanted to mention really quick here. They do sell a foot pedal for just the regular squeezer. So this, you bring in your compressed air, your 90 psi air, and then there's the foot pedal, and then there's a tube here that it goes to the squeezer. And I've never tried this either, but it might be worth it. It's a couple $100 if you're going to squeeze a lot of rivets. I don't know exactly how well your foot can control the squeezer. The nice thing about the least the Cleveland Aircraft Squeezer, is that you can feather the control. You can bring the ram up slowly right to the edge of the rivet, and when everything is set exactly in the right position, the way you want it, then you push this lever, the final little distance, and it squeezes the rivet. Now, whether or not you can do the same thing with your foot, I don't know. I would assume that you can. Otherwise, it would not be very popular or useful. But that would be, you might want to contact Cleveland Aircraft before you actually buy one of these to see if that is indeed the case. Okay, you're going to need some sets. Oops. Okay, so these are just the sets that go in the squeezer. One end goes in the top of the yoke, or one set would go in the top of the yoke, and then one set would go in the ram. And these are just the normal flat sets for using flush head rivets. That looks like a flat set. Oh, all of these are just flat sets. They also sell the appropriate sets for round head rivets. But what I actually wanted to talk about was these flat squeezer sets for doing trailing edges. And I think that they're great. I would highly recommend these. It's only $36, which, it's not insignificant, but when it comes to doing the trailing edge, typically you back rivet it, and in order to hold everything in place, you use either Pro-Seal fuel tank sealant, or you use this new super duper 3M double-sided tape to hold everything in place. However, if you use these special trailing edge squeezer sets, you don't need any of that. So the $36 that you spend on buying this set, or this pair of sets actually, each little piece is called a set. The Pro-Seal is going to cost you that much. So, well, maybe not quite that much, but I found that they work very well, produce good results, and I highly recommend them. Now, I have a couple of little tips here. One is, what you're doing is the whole purpose of these is so that you can squeeze a trailing edge, something that's not flat, something that's tapering down to a point. And so these each, I don't know if you can see the taper in this picture here, but it's tapered, and that's the whole purpose of the thing, is so that it squeezes the rivet appropriately on a tapered edge. So you want to, one thing you want to do is you want to make sure you buy the blue one. The red one is for only to be used on the RV14 elevators, okay? So unless you're building RV14 elevators, you want the blue one. Then you want to make sure that, you know, since they're tilted, that they're always tilted the same way, you know, and they're tilted correctly for the trailing edge that you're riveting. So all you have to do is put a rubber band between the, basically right here, and then the back of the yoke, and that'll hold it in place. Very simple, very easy thing. Let's see, I already mentioned that you don't need the fuel tank sealant or the double-sided tape. Vans says when you're doing a trailing edge, not to use a larger rivet to fill up the hole. It's dimpled on both sides, so your shop head is going into a dimple. Van says not to make the shop head too large. I found that going one size bigger was no problem at all. And I don't see any problem with actually filling the dimple a little bit more, as long as it's not actually sticking out. It seems to me like it's got to be a little bit stronger. And I believe that Vans' advice is based solely on when you're building your trailing edge by using back riveting. And you just don't want a longer rivet because you'll bend it over and misset it. But with these new squeezer sets, I don't know, I thought it was no problem. And then the last tip is to build the airfoil training project. It's RV training project number 1. I believe Van sells it for about $63, something like that. And it has a trailing edge, and so practice on it. However you're planning on doing your trailing edges, if you're going to be using these new squeezer sets for trailing edges, then use those on your practice project. If you're going to do the Pro Seal thing or the Scotch double-sided tape thing, then do that on the end. If you're going to do the back riveting, then do that on your practice project. You know, when the time comes to do something real, you'll have already practiced and you'll know exactly what to do. Okay, the next item on the list is a rivet gun. And this is the standard rivet gun that Cleveland Aircraft Tools sells. Unfortunately, right now, it looks like it's on back order. It's not a particularly unusual item. I don't know why it's on back order. I would assume that it's going to be available again shortly, probably within weeks. There's two basic options when it comes to rivet guns, the 2X and the 3X. The 2X gun is not as powerful as the 3X. There are even stronger rivet guns. There's probably a 4X, a 5X, and a 6X, or whatever. The great big huge rivet guns for giant rivets. But for building an RV, your basic options are either a 2X or a 3X. And I recommend the 3X. And there's a picture of the 2X gun. I think it's basically the same price. And the reason I recommend the 3X Rivet Gun is because I also recommend this inline airflow restrictor. And this is also the standard recommendation for Cleveland aircraft tools. So you put this right on the end of your gun and use it to regulate the flow of air into the rivet gun. So you just leave your shop air at 90 psi, and then you adjust the rivet gun by adjusting the needle valve in this flow restrictor. And this one is actually, I think, pretty reasonably priced compared to other aircraft tools. Harbor Freight sells one that is also a flow restrictor, and it's significantly cheaper. It's about half the price, a little less than half the, well, on sale, it's less than half the price. Regular price is probably a little more than half the price of this. However, the one that Harbor Freight sells is just a ball valve. So from full closed to full open is just a quarter of a turn. So it's very, very sensitive. It would be very hard to set up your rivet gun accurately and consistently. This has a needle valve, and it also has click adjustments. This is, I don't know, what do you call it, serrated or whatever. And so you can easily get back to exactly where you were before. You know, if you switch from a type 3 rivet to a type 4, and then you want to go back, you know, it's very easy. Once you know, for a type 4 rivet, you want to go 3 clicks to the left, whatever. And, you just go 3 clicks back to the right when you go back to the type 3 rivets, and your gun is all set. It's very nice. Highly recommended. Okay, then you're going to need a set for your rivet gun. And this is the standard mushroom set that Cleveland Aircraft Tools sells. And I recommend that you watch their videos that are listed here. And they go into some detail about why they prefer a mushroom set as opposed to just a flat set, for example. So this is actually has a curved surface. That's why it's called a mushroom set and not just a flat set. And it allows you to get the end of the set right on the head of the rivet. Let me show you the alternative. Okay, one alternative that you might want to consider is something like this. And this is just a flat flush set with a rubber collar around it. And it's also has a swivel so that it's tiltable, which sounds nice. I bought one of these, and I never use it. I don't really recommend it. I very much like the mushroom set that Cleveland Aircraft sells, and I like their method of riveting. So the standard recommended method of riveting, the Cleveland Aircraft method, requires 3 hands. Okay, that means you got to get somebody to help. You want 1 hand on the rivet gun, you want 1 hand on the mushroom set, and you use that hand, which is going to be your left hand or your non-dominant hand, to hold the set in place. And it sounds like you're going to pull the trigger on the rivet gun and you're going to smash the crap out of your fingers. But it turns out that that's just not true. Okay? So the first time you do it, turn down the air pressure or use the inline flow regulator and turn the rivet gun way down, and just hold the set with your non-dominant hand and pull the trigger on the rivet gun, and just put the mushroom set up against a 2x4 or something, and convince yourself that you're not going to smash the crap out of your fingers, and then start turning up the air pressure, and you'll find that it's very easy to control the position of the set very accurately with your left hand, and control the gun with your right hand, and you're never going to have any smileys or any dents in your skins or anything like that. Now, that means that somebody else has got to handle the bucking bar, and that's why you need the 3rd hand. And it turns out that once you know how to hold the rivet gun and the set with 2 hands, that's very easy. The least experienced person should be doing that, and the most experienced person should be holding the bucking bar. That's the hard part. That's my version of the Cleveland Aircraft version of how to rivet. Watch their videos, and maybe they explain it a little bit better than I did. Let's see. Okay, I already mentioned bucking bars a little bit. You're going to definitely need 1 or more bucking bars. This is the standard Cleveland Aircraft Tools bucking bar. It's tungsten. Because it's tungsten, it's very expensive. Well, pretty expensive. Compared to the total cost of building an RV10, it's not all that expensive. The advantage of tungsten is it is very dense. I don't remember the exact number, but I think it's close to 3 times the density of steel. I think it's at least twice the density of steel, and it might be somewhere closer to 3 times the density of steel. So it allows you to get a lot more mass right up behind the rivet where you need it. And unless you're very strapped for cash, I highly recommend you go with a tungsten bucking bar. Now, one of the tips here is that orientation matters. Okay, so this bucking bar is 4 inches long, And one easy way to use it is to put the rivet right there where my pointer is pointing, okay? And that works just fine, except for the fact that you have this basically 4-inch lever, and the rivet is going to be pounding on this end of the bucking bar, and it's going to make the other end of the bucking bar vibrate. And so one tip is you can put some tape around the back end of your bucking bar. I would use a heavy-duty tape of some sort, like a duct tape or a Gorilla tape or something like that, and maybe even a couple of layers of tape around the back of the bucking bar, so that if it vibrates around, it won't scratch everything up. But one other alternative is this is the same type of bucking bar. It just weighs less. The first one weighed 1.6 pounds, and this one only weighs 1 pound. So it's just a little bit smaller bucking bar. This is the one that I wanted to show. It's a smaller, well, it is not as long, but it is the same weight. It's the same volume, same mass as the first bucking bar. Not quite. It's 1.5 pounds instead of 1.6, but it's basically the same. So I don't have one of these, and I kind of wish I did. I may buy one. It allows you to get more mass right up behind the rivet where you want it. And you don't have so much of a lever sticking out like I described. So if you haven't bought your bucking bar yet, I recommend that you consider this one as opposed to the other one. I think there's only a couple of reviews here. Read any reviews that you can find. Call up Cleveland Aircraft and talk to them and ask them what they recommend. It's possible. They're fairly friendly, I think. They may sell this one to you, let you try it out for a few weeks or something, and if you don't like it, let you swap it for the other one. So if you have experience with this bucking bar, please leave a comment on this video about how you like it. There are a zillion other bucking bars available. Most of them are steel because they're a lot cheaper. Instead of being $178, they're more like $20. And they come in all different sizes and shapes. But I recommend that you buy at least one tungsten bucking bar. You might want to buy a steel one just so that you appreciate the tungsten one. I think you'll find that you never use the steel one. But just look around, look on Amazon, Google it, whatever. Like I said, there's a zillion different sizes and shapes of bucking bars available. Other tips. The bucking bar, the rivet is going to be pounding on it, so it's going to be vibrating like crazy. It may seem kind of obvious, but it wasn't to me initially. Just try wearing a glove. Harbor Freight sells some, I think they're nitrile coated but it's kind of a woven fabric knit type backing. And so it's a fairly soft glove, but it still gives you reasonable dexterity. And they're cheap. It's like maybe $3 a pair. So something like that, I think, will help. It'll reduce the fatigue on the hand that you're using to hold the bucking bar. Another thing that people often do that I haven't found all that useful, but it's pretty common, is people put a piece of tape either over the rivet, but more often on the mushroom set. And it's just a piece of masking tape, you know, like 1 inch by 1 inch square. Or actually you can use like a 6-inch piece of masking tape, and then as you pound holes in it, you can just move it down. But I think part of the idea is it helps a little bit to keep the mushroom set from moving around. Provides a little friction there. And also it provides a little bit of protection for the skin around the rivet. Makes it a little bit less likely that you put in scratches or dents into the skin. And I already talked about using 3 hands to rivet. That's a Cleveland aircraft tip. Okay, back riveting is pretty straightforward. You're going to need a back rivet plate, and it's just a steel plate. Seems like you could probably find a cheaper steel plate somewhere. I don't. It's a quarter. This one is a 1/4 inch thick, but it's nothing special. It's just a plain ordinary steel plate. And you are going to need a back rivet set for your rivet gun, and that's the standard one. And it's pretty straightforward. I don't have anything in particular to say about it. Works fine. It's not all that expensive. I don't know if you can find a cheaper one somewhere or not. And there are alternate back rivet sets. That's a long one. That one is 12 inches long. And there are also offset back rivet sets, like that one right there. And if you need one, buy it. I believe that this one here comes with the RV10 kit that Cleveland Aircraft sells. Okay, indirect riveting is not so straightforward. It's not straightforward at all. Well, I guess the concept is straightforward, but putting it into practice is definitely not easy. I messed around with it and tried, and I never got very good results. But the idea is simple. You have these little areas, these wedges where the rivet is extremely hard to get to. You can't get the squeezer in there. You can't get the mushroom set in there. There's basically just no way to rivet it. So you can try this indirect riveting thing. Just get a steel bar, get the thickest steel bar that will fit in there over the rivet. You want something very sturdy. And then you pound on that steel bar as close as you can to the rivet. You can see in the picture there, I got this picture just off of the internet of somebody trying to demonstrate how to indirect rivet. So like I said, the concept is pretty simple, but getting it to work right is not so easy. So in one of the videos, Mike at Cleveland Aircraft Tools talks about this, and his recommended solution is just to use a blind rivet in cases like this. There's very few cases like this. I mean, it's probably, like less than 1 in 1,000, probably more like 1 in 2,000 or 3,000 rivets where you're going to have this problem. Just having a few blind rivets in there, use Cherry Max rivets or something like that, probably a perfectly acceptable solution. And I think I already mentioned, well, maybe not about indirect riveting, but practice using the training project, the airfoil training project. It has 2 rivets. The last 2 rivets are very difficult to get to, and I believe that you can use one of those thin nose squeezer yokes to get to the next to the last rivet. But the last one right up at where it nicks down there, it won't fit. So again, figure out when the time comes and you actually have something real that you're going to have to rivet. Have practice on the practice kit, so you know what you're going to do. And if you're going to do this indirect riveting thing, you may have to drill out. You may have to try it, mess it up, and drill it out. 4, 5, 6 times or more before you get it right. So you definitely want to be doing that on the practice kit and not on something real. So I think that's it when it comes to indirect riveting. Okay, removing rivets. You're definitely going to mess up some rivets eventually. There's a zillion different ways to mess up a rivet. I think in Chapter 5 of the instructions, Vans has some drawings of some different ways that you can mess up a rivet. And in addition to that, no rivet is ever going to be perfect. So you got to decide, when is it bad enough to drill out? And in one of the videos, Mike at Cleveland Aircraft Tools, his answer to that question was almost never. That almost always drilling the rivet out and putting in another one, it ends up worse than the first one. And I basically agree with that. Maybe it's just because I don't have enough practice at drilling out rivets. But anyway, that's my recommendation. There are two good YouTube videos here about removing rivets, and one is from Van's Aircraft. Scott McDaniels is one of their DARs, and it's called Rivet Removal Techniques with DAR Scott McDaniels. And there's also a Metal Magic video called Removing Bad Rivets. I recommend that you watch both of those videos, and I also recommend that you take your airfoil training project after you're done, and you drill out all the rivets and you redo them. I know you're not going to want to do that. You just spent some time building this thing, and it's nice, and you spent $1 zillion buying the tools to build it, and the last thing you want to do is just to take it all apart. But you really should. At least drill out, I don't know, 10 or 20 of the rivets, and so that you get plenty of practice drilling out rivets. Drilling out flush rivets, flathead rivets, is not too difficult because they have that nice little dimple in the top. And you can take a countersink, a center punch, and you can use the center punch to make that dimple a little bit bigger, so that your drill bit is centered right on the center of the rivet that you're trying to drill out. And so that, like I said, they're not all that difficult. Now, a dome head or a universal head rivet is much more difficult because the drill bit can just slide right off the dome head. So Cleveland Aircraft Tool sells this rivet removal tool for dome head rivets. Again, just like everything else, it's not cheap, but it might be worth it. Hopefully you won't have very many dome head rivets that you have to drill out. But it is nice to have that tool around if and when you need it. Let's see, another tip that I have is when you're drilling out a rivet, I really like the Nova palm drill. Again, it's a little bit more expensive. I think you can get it from Pan American Tools for less than $300, about $275 or somewhere in there. And it's probably about $350 or so from Cleveland Aircraft. So it's not a cheap drill, but it works really well, especially when you're trying to do something precise and critical like drilling out a rivet. So Van's Aircraft recommends that you take a pair of side cutters and you grind them down, and then you can use those for removing rivets. Personally, I think that's kind of silly. You can just buy a pair of flush cut pliers. There's no particular need to make your own tool. Maybe back in the old days, these tools weren't available, but you can go to Harbor Freight, and for $3, you can buy this little pair of flush cut pliers. And this pair is really made for electrical stuff. So it might not be quite as hefty and durable as you'd like, but they do sell a better pair. And so for $30, you can buy a very good pair of flush cut pliers. Or if you want, you can buy yourself a pair of side cutters and grind them down. But I think I would probably just start off with the $3 Harbor Freight pair and see if that works good enough. Okay, another thing that you should know about is Oops rivets. So if you drill out a rivet and you kind of mess things up, in particular you mess up the hole, you can drill the hole out. If it's a number 3 rivet, you can drill it out to the next size, which would be a number 4. And then you can use an Oops rivet. An Oops rivet has, the body of the rivet is the larger size. So like I said, it would be a size of a number 4 rivet. But the head of the rivet is the same size as for a number 3 rivet. And in my opinion, Oops rivets would be very dangerous. I don't think the head of the rivet is going to hold very well at all. And I haven't gone down to the shop and actually measured one and to see how strong it is. But I suspect it's going to be very weak. And my recommendation is not to use Oops rivets unless you're just absolutely desperate. And try and find some other solution to your problem. But I wanted to let you know that they do exist, and it is a possible alternative. Okay, there's lots of YouTube videos about riveting. Here's 5 of them, 5 Metal Magic videos, and they're all good. They're not that long, and I recommend that you watch them all. Some of these I probably already mentioned. I'll, of course, put the list in the description for this video. And I've mentioned several of these Cleveland Aircraft Tools videos already. And again, I'll put this list in the description. And I recommend that you watch all of these. Like I said, most of these are fairly short, easy to watch, very useful, highly recommended. Just, you don't have to buy their tools to watch their videos. Watch their videos, learn what you're doing, what to do, how you want to do it. And if you want to buy their tools, fine. If not, buy somebody else. Buy something cheaper somewhere else. Great, you can do that. Okay, that's it for this video. As usual, if you want to recommend these videos to other people, the way to have the YouTube algorithm do that is to subscribe, give it a thumbs up, and to leave a comment. And I have several subscribers now, and interestingly enough, I have very few comments. So don't be shy about leaving a comment. One thing that you should know is that if you don't comment on any of these videos, I'm going to assume that everything is okay. That you like them. if you think that they're too long, too short, whatever, leave a comment so that I know about it and I can try and adjust. As usual, I'll try and put all the links for anything I talked about in the description for this video. And I've already mentioned that there's going to be a part 2. Hopefully that'll be out in a few days. And it's going to be about the strength of rivets. So, thanks for watching.